Let's check for the first option. It is 1 upon log 2 to the base 3. So that will be 1 upon log 2 to the base 3 plus 2 upon 4. We can write it as, okay, for the power in the base, we are having the property a to the power n is equals to 1 upon n log m to the base. So this will be log 2 to the power 2 and 3 to the power 2 and minus 3 upon log 2 to the power 3 upon 3 to the power 3. So the first term will be 1 upon log 2 to the base 3. The second will be 2 upon this 2 will come out and this will be in division. So that will get cancelled out. So we will be getting 2 upon log 2 to the base 3 and 3 upon this will come in the multiplication and this will come in the division. So this will be again get cancelled out and we would be getting log 2 to the base 3. So we can see that this is 3 upon log 2 to the base 3 and this is equals to minus 3 upon log 2 to the base 3. Now this value is 0. So one option is correct. These are the multiple choice questions. Let's check for the second option. So for the second option, log 2 by 3 to the base 2 and this will be log 3 by 2 to the base 2 and this is 2 to the power 2. So this will come in multiplication and this will come in division. So we'll get cancelled it out and log 2 by 3 to the base 2 plus log 3 by 2 to the base 2, that will be log 2 by 3 into 3 by 2 to the base 2 and that will be log 1 to the base 2 which is 0. So second option is also correct. Let's check for the third option. So 16, we can write it as minus log 8 log 4 and log 16 will be 2 to the power 4. So that 4 will come here and this will be log 2 to the base 2. So this value will be 1. Now this 4 to the power log 4 to the base 4, this will be again equals to 1 and log 1 is 0. So C is also 0. Now checking for the D option, we are having log cot 1, cot 2 degree, cot 3 degree and so on up to cot 89 degree. So if we will use the property of log, then it will be cot 1 degree and cot 89 degree can be written as cot 90 degree minus 1 degree. So that will be tan 1 degree. Similarly into cot 2 degree and we will be having from here the second last term will be tan 2 degree and so on. We would be having cot 44 degree into tan 44 degree and the last middle term here will be cot 45 degree. That will come only once. So all these will get cancelled out and cot 45 we all know that its value is 1. So this will be log 1 to the base 10. So this will be again 0. So all the options are correct. A, B, C, D. Good. Now moving to the next question. Our next question is, we are having a number n which is equals to 1 plus 2 log 2 to the base 3 whole upon 1 plus log 2 to the base 3 whole square plus log 2 to the base 6 and that's whole square. So we have to find the value of n. So here, okay, so here we need to find the value of n. So we can write it as 1 plus log 2 to the base 3 plus log 2 to the base 3 divided by 1 plus log 2 to the base 3 whole square plus log 2 to the base 6. So we can write it as 1 upon log 6 to the base 2 whole square, and the above one you can write it as you can write log 3 to the base 3, and this will be log 4 to the base 3. So this quantity will be log 12 to the base 3, and denominator this will be 3 to the base 3. So that will be log 6 to the base 3 whole square. So this is plus, let's not change this one right now. Let's write it as log 2 to the base 6 into log 2 to the base 6 only. If you will take it up, that will be log. From the base change property, you can rewrite this as log 12 to the base 6, and this we can write it as log 3 to the base 6. So is there a way we can change it? This will be 3 into 4. Again, rewriting it at 3 into 4 will not make any good sense here. Let's not do it like this way. So what we can do here is, the first method was cool enough. Let's rewrite it as 1 plus log 2 to the base 3 plus log 2 to the base 3 divided by 1 plus log 2 to the base 3 whole square plus log 2 to the base 6 whole square, and this will be log plus log 2 to the base 3 upon 1 plus log 2 to the base 3 whole square plus log 2 to the base 3 upon 1 plus log 2 to the base 3 whole square plus log 2 to the base 6 whole square. Now this one time it will get cancelled out, and we would be getting this. We can write this one as log 3 to the base 3. So we will be getting log 6 to the base 3. And this quantity is log 2 to the base 3, and this quantity will be again log 6 to the base 3 whole square plus log 2 to the base 6 whole square. Now you can write as log 3 to the base 6 plus, again this will be log 6 to the base 3, and from the base change property, log a to the base c upon log b to the base c is equals to log a to the base b. So this will be log 2 to the base 6, and if this will come out, so this will be log 3 to the base 6 plus log 2 to the base 6 whole square. So we can take out log 2 to the base 6 common. We will be getting log 3 to the base 6 plus log 2 to the base 6. So we will be having log 3 to the base 6 plus log 2 to the base 6, and this will be log 6 to the base 6, that will be 1. And this will be again log 6 to the base 6, so it will be 1. So the value of n on simplification is 1. So let's see, it is not a prime number, it is not an irrational number, it is a real number less than log pi to the base 3, obviously, because pi is 3.14 to the base 3, obviously this value is greater than 1, and we are having the value 1, which is less. and it is a greater number log less than greater than log 6 to the base 7, obviously this value will be less than 1. So we are having the value 1 which is greater. So the correct options are C and D. Clear? Moving to the next question. Which of the following numbers are positive? So for the first one, see, for if we are having the value of log a to the base b, then always check if b is greater than 0 less than 1 and a is greater than 1, then this value will be negative. And if b is greater than 1 and a is less than 1 and obviously greater than 0, then this value will be negative. These are the two basic conditions. Okay, we have to check for a as well as for the base. So here what we are having is log of 1 by 2, and so for negative and for positive log a to the base b, either both a is greater than 1 and b is greater than 1, then positive, or a is less than 1 and b is also less than 1. Obviously they should be greater than 0, then this is positive. So here this value is less than 1 and here 1 by 2 is less than 1. So this gives us a positive value. Again here if we will see for the b1, then it is log power is negative, so that will be 3 by 2 to the power 2 by 3 to the base 2. So this quantity is greater than 1 and 2 is obviously greater than 1. So when both are greater than 1, then it is positive. Here log 9 to the base 10 is less than 1 and here 10 is greater than 1. Okay, so we are having this value negative, and here sine whatever be the value or whatever be the angle, obviously the value of sine is less than 1 and this quantity is more than 1, so this will be negative quantity. So this is not the option. So correct options are A and B. Clear? Moving to the next question. Now we are asked which of the following are correct. Let's check for the first one. It is log 19 to the base 3 into log, or we can use the base change theorem, 19 upon log 3, log 3 upon log 1 by 7 and log 1 by 7 upon log 4. So this will get cancelled out and we will be getting log 19 upon log 4, that is log 19 to the base 4. The property which we are using here is log a to the base b is equals to log a to the base c upon log b to the base c. Okay, we can take any log here, e you can take or 10 you can take. Okay, but you have to take the values same. So we are having log 19 to the base 14. So we know that log 16 to the base 14 will be log 4 square to the base 4, that will be 2, log 4 to the base 4, that is 2. So here the value is more than 16, it is 19. So obviously this value will be greater than 2. So our first option is correct. Now for the second one, we are having log 1 by 23 to the base 5. So log 23 to the power minus 1 to the base 5, that will be negative of log 23 to the base 5. We know that log 25 to the base 5 is 2. So log 23 to the base 5 is less than log 25 to the base 5, that is, it is less than 2. multiplying by negative sign, so it will be greater than -2. And since this value is obviously a positive quantity and greater than 1, so this value will be less than -1. So we are having this value lying between -2 and -1. So B is correct option. Checking for the C option, we are having again one more property of log, and that property is a to the power log m, or we can say log k to the base a. This value is equals to k. So using this property, we can say that m is equals to 7. And for n, we can rewrite n as n equals to 3 to the power -2 minus 2 to the power log 7 to the base 3. So n will be equals to 3 to the power 4 log 7 to the base 3. So n will be equals to 3 to the power log 7 to the base 3 to the power 4. This implies that n equals to 7 to the power 4. So n equals to m to the power 4. This is the correct option. Now let's check for D. For D, we are having log sine pi by 5 and 5 to the power 1 by 2, that will be 2 here, and here also that will be 2 into log 5 and in the base sine pi by 5. So from the base change property, we know that log a to the base b is 1 upon log b to the base a, and from this we can say that log a to the base b into log b to the base a equals to 1. So these two quantities will cancel out and we will get 4. And 4 is not an irrational number, it is a rational number. So option D is not correct. So the correct answers are A, B and C. Now moving to the next question. We are given x1 and x2 are the solutions of this equation. So we are having here uh, let's take log base 10 both sides. So this will be log x 3 log x to the base 10 whole cube minus 2 by 3 log x to the base 10 equals to log 10 to the power 2 into 10 to the power 1 by 3, that will be 7 by 3 to the base 10. So from the property of log, these terms will come inside. We will be getting 3 log x to the base 10 whole cube minus 2 by 3 log x to the base 10 into log x to the base 10 equals to 7 by 3. Log 10 to the base 10 will be 1. So to simplify it, let's say log x to the base 10 equals to t. So we are having 3t square minus 2 by 3t into t equals to 7 by 3. On simplification, we will be getting 9t cube. Oh, sorry, t cube it was. So 9t to the power 4 minus 2t square whole upon 3 equals to 7 by 3. So we will be getting a quadratic, or we can say a quadratic in terms of t square. So on splitting the middle term, that will be minus 9t square plus 7t square minus 7 equals to 0. So we would be getting t square minus 1, and we would be getting 9t square plus 7 equals to 0. So this value can never be 0 because square is a positive quantity and adding the positive quantities won't give us 0. So this implies t square equals to 1. Now we are having log x to the base 10 equals to t. So t is equals to plus minus 1. So this is equals to plus 1 as 1. So x will be either equals to 10 or x will be equals to 1 by 10. So let's say this is x1 and x2. So x1 into x2 is 1 obviously. Secondly, x1 plus x2 is x1 plus x2 equals to x1 into x2. Obviously not 10 plus 1 by 10, 10.1. And now log x1 to the base x2. So log x1 will be, okay, we have to take any one quantity x1 and x2. So there is a possibility that this value is equals to minus 1. We are not given here the condition that x1 is greater or x2 is greater. If we are taking x1 is less than x2, so this will be interchanged. We will be getting x1 1 by 10 and x2 10. So this will be 10 to the power minus 1 to the base 10. So minus 1 obviously. So C will be the correct option. And log x1 x2, it is x1 x2 is 1 and log 1 is 0. So D is also a correct option. Since it is given that C is a correct option, so this condition was not there. Clear? Now moving to the next question. The solutions of the equation where base of the algorithm is 10 are. Since we can see here that base is same both the sides, so power should be equal, or either the base should be 1. So base will be equals to 1 when x will be equals to 2. So x equals to 2 is obviously one factor. Now let's check for the others. So we will be having log x whole square minus 2 log x using the property of log. It is equals to 3. So log x whole square minus 2 log x minus 3 equals to 0. You would be getting log x minus 3 into log x plus 1 as the factors. So we would be having value of log x equals to 3 or log x equals to minus 1. We are given that it is base 10. So x will be equals to 10 to the power 3 or x will be equals to 10 to the power minus 1. So the correct options are A, B and C. Okay, x equals to 2 is correct because when the bases will be 1, then whatever be the power, they are always equal. Moving to the next question. We have to find the solution set of mod of x plus 1 upon mod x plus mod of x plus 1 equals to x plus 1 whole square upon mod x. So x plus 1 whole square is same as mod of x plus 1 whole square. So we can rewrite it as mod x plus 1 upon mod x plus mod of x plus 1 minus mod of x plus 1 whole square upon mod x equals to 0. From this, we can take out mod x plus 1 common. We would be left with 1 upon mod x plus 1 minus mod of x plus 1 upon mod x equals to 0. So we can see that from here, this quantity will be 0 when x is equals to minus 1. Now, to simplify this, we have having the two values at mod. We know that mod of x plus 1 will be equals to x plus 1 for x greater than equals to minus 1, and it will be minus of x plus 1 for x less than minus 1. Similarly, mod x will be equals to x for x greater than equals to 0 and minus x for x less than 0. So we can see that on number line, if we'll plot it, then we are having the 2 points, or we are having the 3 zones. So let's take this zone first. So case 1, when x is less than minus 1, obviously in that case it is less than 0, so we would be having minus x plus 1 minus of minus x plus 1 upon minus x equals to 0. So on solving it, we would be getting minus 1 by x plus 1 plus x plus 1 upon x equals to 0. So LCM minus 1 plus x plus 1 equals to 0. So we would be getting x equals to 0. Since we are not considering x equals to 0 in here, so it is not possible. Now, let's go to the second region, that is where x is belonging from minus 1 to 0. So when x is belonging from minus 1 to 0, we would be having this quantity positive, that is mod of x plus 1 will be positive, but mod x will be negative. So we will be having minus 1 by x plus 1 minus x plus 1 upon minus x. So we are having negative sign now. Okay, so this will be negative only. So x and minus x will get cancelled out. Obviously, we are having, and this will be minus of 1. So minus 2 equals to 0, which is not possible. So there is no solution in this region. Okay. Now for this region, we are having minus 1 by x plus 1 minus of x plus 1 upon minus x equals to 0. So we are having minus 1 by x LCM. We will be having minus of minus plus sign. So minus 1 plus x plus x plus 1 equals to 0. So this will get cancelled out and we will be getting x equals to 0, which is not possible, obviously, because the denominator can never be 0. From the question only we can see that x can never be 0. So this is not possible. We are left with the last case or last region where x is greater than 0. So for x greater than 0, we can check it. We would be having it as 1 upon x plus 1 minus x plus 1 upon x equals to 0. In x LCM, we will be having 1 plus x minus 1. So that is 0 equals to 0. This condition is satisfied for all the values of x greater than 0. So the correct option is, oh sorry, not A. Correct option is B, this and union x equals to minus 1, which we have got from here. Okay. Now moving to the next question. we have to simplify this inequality, that is find the region where x will belong. So solve this inequality. So we are having log x square minus 8x plus 23. So it is having base 2 here, so let's change the base to log base 2, and this will be mod sin x to the base 2 is greater than 3 upon log of mod sin x to the base 2. Here we can see that log of mod sin x to the base 2, this value is less than 1 and this is greater than 1, so this value will be negative. So if we are cancelling the two terms or multiplying both the sides by log mod of sin x to the base 2, then the sign of inequality will change. So we would be having x square minus 8x plus 23 to the base 2 is less than 3. Okay. So for logarithmic inequalities, if we are having log a to the base b less than c, then a will be less than b to the power c, and OA will be greater than b to the power c is determined by b. If b is greater than 1, then the sign of inequality remains same, but if b is lying between 0 and 1, then the sign of inequality changes. Here base is 2, so the sign of inequality will remain same, and we would be getting x square minus 8x plus 23 less than 2 to the base 3, that is 8. So we would be having x square minus 8x plus 15 less than 0, that is x minus 3 and x minus 5 less than 0. If we will plot it on the number line, then we are having 3 and 5 in here, and the region which is satisfied is less than 0, that is this is our region. But we can see here that denominator term can never be 0. So log of mod sin x to the base 2 can never be 0. First of all, sin x can never be 0, so x can never belongs to n pi. Secondly, this sin x cannot be equals to 1 or minus 1, because if it will be equals to 1 or minus 1, then log 1 will be 0 and denominator cannot be 0. So x cannot be equals to odd multiple of pi. Now after 3 we would be having pi, then we would be having 3 pi by 2, then we would be having okay, till 3 pi by 2 only we have to we are concerned. Okay, because then we will get 5, because 3 into 3.1 or by 2, this will be nearly equals to 4 point something, so we will get 5 in there. So the value of x can be from 3 to pi, from pi to 3 pi by 2, and 3 pi by 2 to 5. So the correct option is option A, 3 to pi, pi to 3 pi by 2, and 3 pi by 2 to 5. Got it? Manvi Arushi. Moving to the next question. Now we are asked which of the following inequalities are incorrect. How we are going to do this is, we know from applications of derivative, if we are having some function fx and we can find f dash x, that is by differentiating it, and if f dash x is greater than 0, then this function is an increasing function, and for an increasing function f of x2 is greater than f of x1 for x2 greater than x1. So when we are having the two different functions, here we can see that we are having a logarithmic and polynomial function, algebraic and logarithmic function, exponential and algebraic function. Answer is both, all the three, ABC. Now let's check for which of the following are incorrect. Okay, so let's check for the first one. We have taken a function fx equals to log 1 plus x minus x upon 1 plus x. Now differentiating it, f dash x will be equals to 1 upon 1 plus x minus, here we will apply divide rule, or in spite of applying divide rule, do one thing, plus 1 and minus 1, then you will be getting log 1 plus x minus 1 plus 1 upon 1 plus x. Now on differentiating, you will be having this will be 0 and 1 plus x to the power minus 1 will be minus of 1 plus x to the whole square, and you would be getting 1 plus x minus 1 upon 1 plus x whole square, so that will be x upon 1 plus x whole square. For x greater than 0, obviously numerator denominator both are positive, so f dash x is greater than 0. Now f dash x is greater than 0, this implies that it is an increasing function. So if we will check for f of 0 or f of x tending towards 0, then log 1 plus x tending towards 0 will be log 1, that is 0, and this was minus of x upon 1 plus x, so 0 upon 1, that will be 0, so it is 0. So f of 0 will be less than f of x, or we can say that f of x will be greater than f of 0 for x greater than 0. So we will be having log 1 plus x minus x upon 1 plus x greater than 0, that is log 1 plus x will be greater than x upon 1 plus x. But the given condition is log 1 plus x is less than x upon 1 plus x, which is not true. So we have to find the incorrect condition. So this is an incorrect condition. So our option is A. Let's check for the other options. You got the basic concept? Now let's check for this one. For this, let's say y is equals to x minus log 1 plus x, so on, we can say fx or y, you can take dy by dx, you will calculate, then it will be 1 minus this, so that will be 1 plus x minus 1 upon 1 plus x, again x upon 1 plus x, which is positive for x greater than 0. So this function is again increasing, and on putting x equals to 0, so y of 0 is 0, and y of x will be greater than y of 0 as the function is increasing. So x minus, writing it here, so x minus log 1 plus x will be greater than 0, so x will be greater than log 1 plus x, but we are given the opposite condition, so this is an incorrect condition. We have to find the incorrect condition, so this is B is also one of our options. Now checking it for C, obviously D is not the answer. Then fx is equals to, let's say we are having e to the power x minus 1 plus x, so f dash x will be equals to e to the power x minus 1. So we know that for x great belonging to any real number, we have to find. So for x greater than equals to 0, f dash, or greater than 0, f dash x will be greater than 0, and f of 0 is 0 obviously. So f dash x, fx will be greater than f of 0. So we would be having e to the power x minus 1 plus x is greater than 0, that is e to the power x is greater than 1 plus x. Since it is not applicable for x greater than 0 and we are given for all the real numbers, this condition should be applicable, but this condition is not applicable, so this is also an incorrect thing and we have to find the incorrect inequality. So this is also one of our options. So the correct options are A, B and C. Now moving to the next question. Our next question is, let a greater than 0, then the inequality under the root a square minus x square is greater than x plus 1, then which of the following options is correct? If you rewrite it as y equals to under root a square minus x square, squaring it, you will get y square equals to a square minus x square, that is x square plus y square equals to a square. This will give us the equation of a circle. And here y equals to x plus 1 gives us the equation of straight line. Now if we will draw xy axis and plot this straight line, then for x equals to 0, y equals to 1, for this. So this is the straight line we are having, which passes through these points minus 1 comma 0 and 0 comma 1. Now this represents a circle. We are not having the value of a, so if the value of a, so the circles can be different. We can get either this circle, we can get a circle which touches the line, or we can get a circle which cuts the line. So we can have the three forms of the circle depending upon the condition of a, that is depending upon the radius. So let's first of all find out what should be the value of radius so that the circle will touch the line. So this is 0 comma 0. So we have to find the perpendicular distance of a point 0 comma 0 from the line. So we can rewrite this as this equals to 0. So the perpendicular distance d will be mod of 0 minus 0 minus 1 upon under the root 1 square plus 1 square. So d will be equals to 1 by root 2. So if we will say a equals to 1 by root 2, the radius will be equals to 1 by root 2, then it will touch it. So there will be only one solution. So option number B is correct. If this value of a is less than 1 by root 2, then we will be having this circle. For a less than 1 by root 2, and obviously it is given that greater than 0, then it will not even touch or not cut. So there will be no solution. So we are having option A correct. Now for the value of d, or we can say the radius, that is a, greater than 1 by root 2, it will cut the line at 2 points. So it will have two solutions. Okay, whatever be the value of a. Okay, for greater than 1 also, then also it will cut it at 2 points only. So D is not the correct option. We are having the correct options A, B and C. Can we move to the next question? Moving to the next question, we are having, let E equals to a square plus b square plus c square upon ab plus bc plus ac, where abc all belongs to real numbers and ab plus bc plus ac is not equals to 0. Then we have to find the conditions on it. First of all, we know that a plus b plus c whole square is equals to a square plus b square plus c square plus 2ab plus 2bc plus 2c. Since the value of square is always positive, so this quantity will be always greater than equal to 0. So you can say a square plus b square plus c square will be greater than equals to minus 2 common ab plus bc plus ca. Now, if we are dividing by both sides by AB plus BC plus CA, then we would be having two conditions. If AB plus BC plus CA is greater than 0, then the sign of inequality won't change. So that will be greater than equals to minus 2. If the sign of AB plus BC plus CA is negative, if this quantity is negative, then the sign of inequality will change. Now we are given the condition that it will be less than equals to 2 for all ABC. No, this is not the correct option. Let's check for the D1. If AB plus BC plus CA is less than 0, yeah, we are having this condition here. So D is our correct option. One option we have got. Now let's check for the value 1 if we can get. So we know that if we have arithmetic mean is always greater than equals to geometric mean, so we can say a square plus b square by 2 will be greater than equals to ab. Similarly, b square plus c square by 2 will be greater than equals to bc. And c square plus a square by 2 will be greater than equals to ca. Adding all these conditions, we will be getting a square plus b square plus c square is greater than equals to ab plus bc plus ca. So a square plus b square plus c square upon ab plus bc plus ca will be greater than equals to 1 only when ab plus bc plus ca is positive. Yeah, this should be given here. So option B is correct. If that value would be negative, that is, if AB plus BC plus CA is less than 0, then we would be have got A square plus B square plus C square upon AB plus BC plus CA less than equals to 1. Okay, sign of inequality would have changed. Clear? So we are having the two options here, that is B and D. Moving to the next question. We are given log x to the base 2 plus log y to the base 2 is greater than equals to 6. So you get say log xy to the base 2 is greater than equals to 6. So xy is greater than equals to 2 to the power 6. We have to find the least value of x plus y. So we know that x plus y by 2 arithmetic mean is greater than equals to root of geometric mean. So x plus y will be greater than equals to 2 into 2 to the power 3. So x plus 5 will be greater than equals to 16. Since xy was 2 to the power 6, so root xy will be 2 to the power 3. So the least value of x plus y is 16. So the correct option is C. Moving to the next question. We have to find the solution set of the equation log 2 to the base x into log 2 to the base 2x equals to log 2 to the base 4x. And rewrite it as 1 upon log x to the base 2 into log 2x to the base 2, and it is equals to 1 upon log 4x to the base 2. This implies that log 4x to the base 2 is equals to log x to the base 2 into log 2x to the base 2. Since we are taking the same base. So 4x we can write it as 2 square to the base 2 plus log x to the base 2, and this is log x to the base 2, and in bracket it will be log 2 to the base 2 plus log x to the base 2. So here if we are taking log x to the base 2 equals to t, so we would be having this power will come that side, so we would be having 2 times of log x to the base 2 is equals to t into 1 plus t. 2 plus t equals to, so we would be having 2 plus t equals to t plus t square. So t square will be 2. T square equals to 2, that is t equals to plus minus root 2. So we are having log x to the base 2 equals to either root 2 or log x to the base 2 equals to minus root 2. So the value of x will be 2 to the power root 2 or x will be equals to 2 to the power minus root 2. So the correct option is option A. Moving to the next question. If the product of the roots of the given equation is 1 upon a to the power 1 by b, then we need to find the value of a plus b. This we must be having in log base 2, okay? So taking log to the base 2 both the sides, we would be getting 3 by 4 log x to the base 2 whole square plus log x to the base 2 minus 5 by 4 log x to the base 2 is equals to log root 2, that is 2 to the power 1 by 2 to the base 2. For simplification, let log x to the base 2 equals to t. Taking LCM, we would be having 3t square plus 4t minus 5 whole upon 4 into t is equals to 1 by 2. So we would be having the equation 3t cube plus 4t square minus 5t minus 2 equals to 0. We can see here that t equals to 1 is one of the factor. So if you are having a cubic equation and you are having one of the factor as means by hit and trial you got one of the factors. So how to simplify it? You can either use the long division method, or what you can do is here we are having t equals to 1 as one of the factor. So write t minus 1 3 times. Now we are having 3t cube here, so we will write 3t square here, because 3t square into t will be 3t cube. Now when you will multiply 3t square with minus 1, that will be minus of 3t square. But what we have here is plus 4t square. So this minus 3t square, so for this minus 3t square we should have 7t here. So that minus 3t square plus 7t square will give us 4t square. Now if we'll see here, then we are having 70 into minus 1, that is minus 70, but we need minus 5t, so we need plus 2t one time more. So we'll be getting plus 2t and minus 2, so this is satisfied. Now if you will take t minus 1 common, so you are having this equation 3t square plus 7t plus 2 equals to 0. Now if you will simplify this equation, I am writing it here, you would be getting t minus 1 and 7 you can rewrite as x6 plus 1. So you will be having the factors 3t square plus 6t, you will take out 3t common, so you will get t plus 2, and you have taken 3t common, so that was 3t, and this, so that will be 3t plus 1 equals to 0. So the value of t is 1, minus 2 and minus 1 by 3. Since we have taken log x to the base 2 equals to t. So when t will be equals to 1, so log x to the base 2 equals to 1, that is the one value of x is 2. Log x to the base 2 equals to minus 2, so x will be equals to 2 to the power minus 2, that will be 1 by 4. And log x to the base 2 will be equals to minus 1 by 3, so x will be equals to 2 to the power minus 1 by 3, and this is 2 to the power 2. On multiplying these three values, let's say this is x1, this is x2, this is x3, we have to find the product of the roots. So we would be having 2 into 1 by 2 square into 1 upon 2 to the power 1 by 3. So on cancelling, you would be getting 1 upon 2 to the power 1 plus 1 by 3. That will be 4 by 3. So this is 1 upon 2 to the power 4 whole to the power 1 by 3. So A is equals to 2 to the power 4, that is 16. And B is equals to 3. So the sum will be 19. So the correct option is B. Okay. So that's all for today. Thank you.